Hello friends, in this video I am going to discuss some important concepts related to common collector amplifier. But before going to that, I will discuss one very important concept related to the negative feedback scheme. Okay, let us check. See, this is one simple block diagram of a negative feedback scheme. Here this is input voltage, original input voltage, that is coming from the, suppose in labs this voltage comes from function generator. Okay, and this is the basic amplifier block with gain A, and this is the output voltage. Some portion of output voltage is sampled, and it is the input of the feedback network whose gain factor is beta, and the output of the feedback network is VF, that is feedback voltage, which is subtracted from the original input voltage. Suppose let us consider the voltage of this differential amplifier, the output voltage of the differential amplifier is V dash. Why I am saying this mixer as differential amplifier? Because it is producing the difference in between input voltage and feedback voltage. So we can we can think that here there is one differential amplifier. We can realize this summation block by a differential amplifier. So basically what we can get, V dash equal to V in minus VF, input voltage, original input voltage minus feedback voltage. So that is equal to V in minus, see carefully, what is the feedback voltage? Output voltage is the input of the feedback network, and feedback voltage is the output of the feedback network. So basically VF equal to V out into beta, we can say. So this basically this is beta into V out. Okay, so basically what we are getting, the input voltage of the basic amplifier block with application of the negative feedback, that is V dash equal to input voltage minus beta, that is gain of the feedback network, into the output voltage with application of the negative feedback. This is very important formula. This will help us in analysis of the CC or common collector amplifier. So let us check. This is the simplest schematic diagram or circuit diagram of a common collector amplifier. See here, the emitter current is coming out of the device. So obviously the transistor is nothing but NPN transistor. Okay. This plus V is the DC voltage source for biasing, and in the base we are giving the input, and in the emitter across RE resistor we are taking the output voltage. Okay, and here no bypass capacitor are present like common emitter. Okay, because we are taking the output voltage across RE. Okay, now as in base the input is given and the emitter output is taken, so obviously the other terminal is the collector. So collector is common in between input and output. So this is called common collector amplifier. Now we will analyze this amplifier with respect to negative feedback concept. Okay, see here, in the base we are giving the input voltage, and in the emitter we are taking the output. See this general block diagram of negative feedback. Here we were providing the input voltage from the function generator, and here we are taking the output. In between output and input there are two blocks. One is basic amplifier block and another one is feedback network. So we can say that for a negative feedback scheme, or for any feedback scheme that is either positive or negative, in between output and input, the block apart from the basic amplifier block is basically feedback network. Okay, similarly see here, this is input, this is output. In between input and output there are two blocks. One is basic amplifier block, that is transistor, and another one is the RE resistor. So the transistor is the basic amplifier block. So from that we can clearly say the RE resistor is basically the feedback network for this common collector transistor. Okay, now let us apply the KVL in the input loop. So basically this is plus, this is minus, this is input voltage. Here it will be base emitter voltage, clear? And here we are taking the V out or output voltage. So if we apply the KVL in this loop, what we can get? Minus V in plus VBE minus V in plus VBE plus V out equal to 0. That's what, right? Minus V in plus VBE plus V out equal to 0. So what we can say about VBE? So VBE equal to basically V in minus V out. Clear? This is very important expression. Now see carefully, here this output voltage is basically, that is voltage across RE is basically feedback voltage for this common collector network. So we can denote this by VF also, that is feedback voltage. Now see what is the original input for the amplifier block. This Vin is basically the input of the whole block, that is basic amplifier along with the feedback network. But if you consider the original input voltage for only the basic amplifier block, that is basically VBE, okay? And here VBE is basically the input voltage which is coming from function generator minus the feedback voltage, okay? And basically V out is V feedback only, so VBE equal to V input minus V feedback, okay? Now see what we can get from this. VBE equal to V input minus V output, and here we got one expression, original input for the basic amplifier V dash equal to V input minus beta into V output. So let us write here. Here the original input for the basic amplifier block is basically VBE. So VBE equal to V input minus beta into V output. Just what I have done, this expression we already derived here. Just instead of V dash, as here the original input for the basic amplifier block is VBE, so we have replaced V dash by VBE and we get this expression. This is the expression we are getting from general amplifier feedback amplifier block, and this is the expression for this particular case. Now see, here we are getting VBE equal to V input minus V output. V output is V feedback basically, and from the general amplifier block we get VBE equal to V input minus beta into V output. So by comparing these two equations, we can clearly say that beta is equal to 1. Okay, this is very important concept for CC amplifier, that for CC amplifier the gain of the feedback network is 1, and you know the formula for overall gain of negative feedback, that is AF equal to A by 1 plus A beta. Okay, that is here A is the basic amplifier gain and beta is the gain of the feedback network, and AF is the gain of the overall gain of the feedback network with application of the negative feedback scheme. Now suppose A beta is very greater than 1, so obviously we can ignore the term 1 with respect to A beta and we get AF equal to A by A beta, and AA cancels each other. So basically what we can get, AF equal to 1 by beta. Okay, so basically for negative feedback we can apply this approximation. This is valid if A beta is very greater than 1, and for transistor, NPN transistor, we can make gain very high by proper biasing and by choosing proper beta value for a particular transistor. Okay, so we can apply this assumption in this case and we get the overall gain for CC amplifier is equal to AF equal to 1 by beta, and here for CC amplifier beta equal to 1, so overall gain is 1. Okay, so you must remember this theory. This is very important concept for the electronics engineering, that is, for common collector amplifier the overall gain of the amplifier block is equal to 1, and the gain becomes unity due to application of the negative feedback, and the negative feedback applied in this case is Re, or the emitter resistor. And also you should remember, while solving problems, you should also remember this concept, that is, for the common collector amplifier the gain of the feedback network is beta equal to 1. Okay, that is unity gain. So basically what we are getting, these two results, that is, number 1 is the feedback gain is 1, and number 2 is overall gain becomes 1 due to application of the negative feedback. Okay, this is very important concept for negative feedback related to common collector amplifier. This is all for this video. In my next video I will show you some more concepts. Thank you for watching.